we're going to talk about how to solve proportions. And a proportion is just a statement that has two ratios set equal to each other. A ratio compares any quantities by division. So a ratio is really just another way to say a fraction. A proportion could be something like 1/2 equals 3/6. It's a ratio equals another ratio. More often than not, what we want to do is solve a proportion. So there's one of those numbers that we won't know. And we use cross multiplication. So we would multiply A times D, because they're on a diagonal, with B times C, because they're on the other diagonal. And we would set them equal to each other. When we have something like number 1, 10 over x equals 2/3, it's very straightforward. We multiply our diagonals, so we'll have 10 times 3 equals our 2 times x. And then we just solve. 10 times 3 is 30. To get that x by itself, I undo multiplication with division and find that 15 equals x. One thing I do want to point out, it does not matter which way you write it. So if you wanted to write your original equation as 2x equals 30 with the x on the other side, that's perfectly okay. Now if we look at number 2, it's a little bit more complicated. There's a variable m in two different places, and on the right hand side we have m minus 3. My recommendation, whenever you see a variable plus or minus a number, put parentheses around it. Because when we cross multiply, we're going to do 2 times m, but we also need to do 5 times that entire numerator. So 5 times m minus 3. So our first step in actually solving this equation needs to be to distribute that 5 to both terms. And if you don't have those parentheses in there, you'll forget about that and just do the 5 times the m. Now once we have this, we need to get our m's on one side and our numbers on the other. So I have to move this 5m even though it's the bigger number, because I want to get all the m's on the side where there is not a number, where there's not that 15. So I'll have negative 3m equals negative 15. Be careful to bring down all those signs. To undo that multiplication, I use division, and I end up with m equals positive 5. If we look at number 3, we have that same issue where we have a variable minus a number and a variable plus a number. So I'm going to put parentheses around it. When I cross multiply, I have 2 times y plus 6 equals 3 times y minus 5. Remember to put your y plus 6 and your y minus 5 in parentheses. Then I'm going to distribute to get rid of my parentheses. So I'll have 2y plus 12 equals 3y minus 15. I have variables on both sides and there's constant on both sides. So I can move my 2y or my 3y. I'm going to move my 2y to try to avoid some negative numbers. So I'll have 12 equals y minus 15. To undo that minus 15, I add 15 to both sides and find that 27 equals y. We can also use proportions to help us solve word problems. This says, to estimate the number of bass in a lake, wildlife biologists tagged 50 bass and released them in the lake. Later, they netted 108 bass and found that 27 of them were tagged. Approximately how many bass were in the lake? So I'm going to set up a proportion. When we set up a proportion from a word problem, we need to make sure that we keep the units lined up. So the good thing is the units are pretty similar here. They're all bass. So we need to figure out the difference between the bass. We have some tagged bass, some netted bass, and then we have tagged bass again. So I'm going to make my numerator my tagged bass. And whatever I make my numerator on one side, I need to make my numerator on the other. That means that just plain old bass or netted bass or total bass, however you think about it, is going to be in our denominator. So I'm going to keep like units across from each other. That means I need things from the same situation on top of each other. So if we look at this, they essentially went fishing twice. So stuff from the first time they went fishing is going to go on my left-hand side, and stuff from the second time they went fishing is going to go on my right-hand side. If I reread the problem and try to put things in the right spot, they estimated the number of bass in a lake, and they tagged 50 bass. So my 50 has to go up top and release them into the lake. Then it says later, so this is my second situation. They netted 108 bass. So that's not the tagged, that's how much they netted. That has to go in the bottom. And they found that 27 of them were tagged. So because that was the same fishing trip, they're on top of each other. Then it says how many were in the lake. So just plain old bass is what I need to solve for, that x in my denominator. Once I have this set up, I solve it just like I did before. I'm going to cross multiply. So I'll do 27 times x equals 50 times 108. When I multiply 50 times 108, I will end up with 5,400. Then to undo that multiplication, I use division, and I find that x equals 200. This is a word problem, so I need to make sure I use my units. I can look back at where I set up my proportion or at what they asked me. I know that my answer, my 200, is how many bass were in the lake. If we look at this one, an alligator's tail length is proportional to its body length. An alligator with a body length of 4 feet has a tail length of 3.6 feet. What is the tail length of an alligator whose body length is 6 feet? I'm going to ask you, pause this and try to set it up on your own. When I set the problem up, this is what I got. Now there are multiple ways to set it up. So a good way to double check that we set it up the same way or equivalent ways is to cross multiply. When we multiply, we should have 4x equals 3.6 times 6. Right? Even if you set it up differently and had your bodies on the bottom or body lengths on top of each other, if you ended up with this when we cross multiply, that's perfectly okay. So when we multiply that 3.6 times 6, we end up with 21.6. And then I solve using my division to find that my x is 5.4. If I look back, that was a tail length. And all of these lengths were in feet.